So part B of 1.9 to 1.10, here we go. So example 3, again, what makes a vertical asymptote? A what? A number over 0. And so at a vertical asymptote, as I approach from the left or I approach from the right, I'm either going to get two answers, one of two answers, or both. I'm going to get to positive infinity or negative infinity, because it's a vertical asymptote, right? And then if I get a hole, something canceled. I got 0 over 0, right? And that's when we can go from both left and the right, but it's still going to be at the same y value. All right? So let's look at example A. So as x approaches 3, is that a hole or a vertical asymptote? It's a hole, all right, because it goes to a pure number. It goes to 5. However, on as x approaches 1, what's going to be at 1? Right. So I have a hole going on at 3. So what linear factor gives me a hole? So at 3, what's going to cancel out? X minus 3. And so x minus 3's are going to cancel out. That's going to create the hole. And then this part is going to create a what? A vertical asymptote. And so when I create a vertical asymptote, what am I going to have? I'm going to have 0 on the bottom at what? At 1. So now I'd have x minus 1 in my denominator. All right? And so if I go back and look at the hole, though, if I go back and look at the hole, and I kind of cover this part up, and so I have a simpler function of 1 over x minus 1 right now. Where do I want my hole to be? I want it to be at 5. And so what will I get on my denominator? Take out this simpler part. If I substitute in 3, what do I get in my denominator? A 2. Well, I want it to be a 5, so something divided by 2 is going to give me 5. So what do I also want in my numerator? A 10. All right, so let's do it again for part B. Where is my hole at part B?
2 or 1.
At negative 2. All right, I'm going to have a hole at negative 2. Where am I going to have a vertical asymptote? At negative 1. All right, and so now let's try to write this one. And so at negative 2, I'm going to have a hole. So what factors are going to cancel? X plus 2's are going to cancel. That's going to create that hole. All right, so we're working backwards on these. And so then what's going to create my vertical asymptote? X plus 1. All right, and so now I'm going to have x plus 1 in my denominator. However, both of them are going to what? Positive infinity. And so when both of them are going to positive infinity or negative infinity, that part's going to be squared. That's the tricky part about this one. All right. And so right now, if I just worry about that part, I have a positive over what's going to be a small positive every time. And so if I have a positive over a small positive, that's going to give me positive infinity. All right. And so that's why that part's working. But now let's talk about its hole. And so again, if I cancel out my simpler function, if I cancel out this x plus 2, if I substitute in negative 2, what do I get in my denominator? 1. I get 1 in my denominator. So what do I want in my numerator? What divided by 1 is going to equal 4? 4. And so that's why I have 4 up top. All right. All right, let's look at example 4 now. So we're going to sketch our picture that has a hole at 1. And then as x approaches 4 from the left, it increases without bound. And x approaches 4 from the right, it's going to decrease without bound. All right, so let's make our little sketch. So what's happening at 4? There's not a hole at 4. Okay, increases and decreases without bound going on, all right? But what's actually happening there? It has a vertical asymptote. So at 4, I'm going to have a vertical asymptote. All right. And at 1, it's going to have a hole. However, if we read this part, as x approaches 4 from the left, all right, so x approaches 4 from the left, it increases without bound. So this is the left of 4. Does everybody agree? And it says it increases without bound. So that means it goes which way? It goes up. And so it's going to go up from the left, and then x has a hole at 1. So it looks something like that. And then as x approaches 4 from the right, it decreases without bound. So from the right of 4, which way is it going to go? Is it going to go up or is it going to go down? It's going to go down to negative infinity. So some kind of graph that looks like that. All right, so let's look at part B now. And I need a good reader. Joshua is going to read this one for us.
All right, it says g of x has holes at x equals -2 and x equals 3. As x approaches -1 from the left, g of x decreases without bound. As x approaches -1 from the right, g of x decreases without bound.
Love it. All right, and so where does it have a vertical asymptote on this one? At -1. At x equals -1, it's going to have our vertical asymptote. And so then it has a hole at -2 and it's a hole at 3, and we'll deal with that in a sec. But when it approaches from the left, it decreases without bound. So from the left of -1, it's going to go which way? Down. And it also says it has a hole at -2, and so now I have that going on. And then as x approaches -1 from the right, it also decreases without bound. But I have a hole at 3, and it decreases without bound, so which way is it going? It's going down again. All right, I'm going to go a step further. I'm going to act like I can find this function. All right, so let's see what this function might be. All right, there's lots of different answers, but let's say what it might be. What's going to create a hole? 0 over 0. So if I have x equals -2 as a whole, what's going to cancel out? What factors are going to cancel out? X plus 2's. So I have an x plus 2 in the numerator and denominator. That would create my hole. Yes? All right, cool. How about x equals 3? What's going to form a hole? X minus 3's also will what? Cancel. All right, that will make the hole. All right, and so then how do I get this vertical asymptote on this part? A number over 0. So what's going to be where? So I have a vertical asymptote at -1. So I have x plus 1. Where's x plus 1 going to be? In my denominator. However, if you notice, what are they both doing? They're both decreasing without bound. All right? And so Campbell said it, it's got to have a degree of what? 2. All right? However, if you think about this one, I have a positive over a positive. And that will always do what? Go to positive infinity. What are these doing? Going down. So what do I want in my numerator? I need a negative. A negative something. It could be -1, it could be -82, it doesn't really matter. However, it's going to be negative. All right? And so that could be a function for that one. All right? Number 10. So this graph has a hole at x equals 3 and vertical asymptotes at 1 and -4. All right? And so what creates my hole? Things canceling out. So what's going to cancel out? X minus 3's. Both of them are going to cancel. And then I have a vertical asymptote at x equals 1. So what do we know there? Not x. Okay, x minus 1 is where? At the bottom in the denominator. And then we also have a vertical asymptote at x equals -4. So what other factor are we going to have in the denominator? X plus 4. So that could be that function. I'd like you to do number 11 and 12 real quick.
You're going to have x plus 1 on the bottom and top because there's a hole at x minus 1.
Love it.
And then you'll have x minus 5 on top and bottom because there's a hole at x equals 5.
Okay, hold up. I got a vertical asymptote at 7.
I jumped over.
It's okay.
You'll have a vertical asymptote at x equals 7, so you'll have x minus 7 on the bottom.
Good.
And then this one is 7.
If I have a 0 at x equals -2, what am I going to have where? I'm going to have x plus 2 where? In the numerator. All right? Also known as an x-intercept. It's the same thing. All right? All right, let's do the last one. Lone Wolf, here we go.
X minus 2 on top and bottom,
Love it.
and then x minus 5 on top and bottom,
Love it. Because those are going to create what?
holes,
Holes. Good.
and then x minus 1 on the top because it's a 0, and then you're going to have an x in front of your
Good. So that will create that number over 0 thing. All right, fantastic.